Hey everyone, and welcome back to Key Safety Talks. No matter where you are or what you do, fire safety is something we all need to know. So today we're going to talk all about fire protection and prevention.
Absolutely. It's one of those things we tend not to think much about, until it's too late. But really understanding the basics can make a world of difference when it comes to staying safe.
I completely agree. Now, I see you've brought a whole stack of resources with you today. It looks like we've got research papers, safety guidelines, even some real-world case
Oh,
studies.
yeah. I wanted to make sure we cover all the angles because fire safety, it's not just theoretical. It's really about taking that knowledge and applying it to those real life situations. So, yeah, we're going to dive into all of that today.
That sounds great. I'm really excited to dig in. And I see one of the first things you have here is about the fire tetrahedron. Um, is that something our listeners should be familiar with?
It is. I'd say more than should. It's crucial, actually. Remember that, that old fire triangle? Fuel, oxygen, heat? We probably all learned that at some point. Well, the tetrahedron, it adds a fourth element to that, and it's the chemical chain reaction.
Oh, okay. So it's not just about having the ingredients, it's about how those ingredients interact with each other.
You got it. And that chain reaction, that's really what keeps a fire going, right? It's like a domino effect. You have heat that breaks down the fuel, releases more flammable vapors, and those vapors, in turn, just fuel the flames even further.
So it keeps going, keeps feeding itself until something breaks that chain.
Yeah,
Yeah.
precisely. Which is why understanding how to extinguish a fire is so, so important. But before we get to that, let's talk about heat transfer in a fire. I mean, that plays a huge role in how fires spread.
For sure. So our sources mention three main ways that heat is transferred: radiation, convection, and conduction.
Right, exactly. So you have radiation, which is heat traveling through space, like, the warmth you feel from the sun. In a fire, the radiation from the flames can actually preheat nearby objects, fuel sources, making them much more susceptible to ignition.
Okay, so even if a fire isn't directly touching something, it can still be heating it up, potentially causing it to ignite. That's kind of scary to think about.
Yeah, it is. And then you have convection, which involves heat transfer through the movement of fluids like air or water. So hot air and smoke, they rise, they carry heat upwards and outwards. Think about like a wildfire, that rising heat, it creates drafts that can actually draw in fresh oxygen, just feeding the flames even more.
Almost like the fire is creating its own wind in a way. That's wild.
Yeah, it is.
And then we have conduction as that third method of heat transfer. Right.
Exactly. So conduction, that's all about heat transfer through direct contact. When
Right.
you think about touching a hot stove, that's conduction. In a fire, conduction can spread heat to adjacent materials like walls or furniture.
Right. So we've got this like trifecta of heat transfer going on: radiation preheating things from afar, convection carrying the heat with that rising air, and then conduction just spreading the heat through direct contact. No wonder fires can get out of control so quickly.
Yeah, exactly.
Now let's shift gears a bit and talk about something you mentioned earlier. So they need more heat to actually ignite things like kerosene or diesel fuel.
Exactly. Knowing these flashpoints, I mean, it's absolutely critical, when you're assessing those fire risks, especially in industrial settings where these liquids are often present. Remember that horrible case of the garment factory fire in Bangladesh a few years back? The investigation showed that improperly stored flammable chemicals played a big role in how quickly that fire spread.
Yeah, that was just devastating. It really does highlight the importance of properly handling and storing these types of materials.
Absolutely.
Okay, so building on this whole idea of flammable liquids, we also need to talk about LFL and UFL.
Okay. Yeah.
Now, those acronyms, I mean, they sound a bit technical. So what do they actually mean, in a practical sense?
So think about it this way, like baking a cake, right? You need the right proportions of ingredients for it to come out right. Too much or too little of something will just ruin it. Well, with flammable vapors in the air, it's the same idea. The LFL, that's the lower flammability limit, and it's the minimal concentration of vapor in the air that's actually needed for it to ignite.
Okay, so below the LFL, there's just not enough vapor to support combustion. And what about the UFL?
The UFL, that's the upper flammability limit. It's the maximum concentration. So above that, there's too much vapor, and the mixture is actually too rich to burn. So for a fire to occur, the concentration of vapor in the air has to fall within that range between the LFL and the UFL.
Ah, that makes sense. It's like finding that sweet spot for combustion.
Exactly. Now picture this. You're working in a factory, right? And they use a flammable solvent. Let's say there's a spill. Knowing the LFL and UFL of that solvent is super important for assessing the risk of fire. If the concentration of those vapors in the air reaches that flammable range, well, you've got a potentially explosive situation on your hands.
Yeah, that's a really powerful example. It shows just how practical these concepts are, in a real-world setting.
Yeah, absolutely.
Okay, now let's move on to another important aspect of fire safety, fire classification systems.
Okay, sure.
Our sources, they mention both the NFPA classifications and the BSEN classifications. Can you kind of break those down for us?
Yeah, definitely. So the NFPA, that's the National Fire Protection Association system, and it's widely used here in the US. It basically categorizes fires into 5 classes based on the type of fuel involved. So Class A fires, those are the ones that involve ordinary combustibles like wood, paper, and cloth.
So those everyday materials we see around us all the time, what about Class B fires?
Class B fires involve flammable liquids and gases, things like gasoline, propane, solvents. Those fires need specialized extinguishing agents that can both cool and smother the flames.
Okay, so using water on a Class B fire would be a bad idea.
Very bad idea. The water can actually spread those flammable liquids, making the fire even worse.
Got it. Okay. Then we have Class C fires, which are fires that involve energized electrical equipment.
Right.
So like a fire in an electrical panel or a malfunctioning appliance, something like that.
Exactly. With Class C fires, the main concern is using a non-conductive extinguishing agent to avoid electrocution. So things like carbon dioxide or dry chemical extinguishers are typically used in those situations.
Okay, so again, choosing the right type of extinguisher is critical. What about Class D fires?
Class D fires, those are the ones involving combustible metals like magnesium, titanium, sodium. Those fires are especially hazardous because they burn at super high temperatures and they can react violently with water. You actually need specialized dry powder extinguishing agents to control those types of fires.
Wow, that's intense. I can see why those would be so hard to put out.
Yeah, they are.
And finally, we have Class K fires, which involve cooking oils and fats.
Right.
So those are the common ones we see in kitchens.
Exactly. Like if a pan of oil catches fire, that's a Class K fire. And they need a specific type of extinguishing agent that can cool the oil and form like a soapy foam blanket to smother those flames and prevent reignition.
So it's like a special firefighting recipe.
It is.
So the takeaway here is not all fires are created equal, right?
Right.
Knowing the correct classification is absolutely essential for choosing the right way to put it out.
Absolutely.
Now, the BSEN classification system, which is more commonly used in Europe, it's similar to the NFPA system, but with a few key differences, right?
Yeah.
Like what?
So for one, they don't have a separate class, like a Class C, for electrical fires. Instead, they consider electrical fires to be either Class A or B fires, depending on, what material is burning after the electricity is cut off.
Oh, interesting. So if you have a fire in an electrical panel, once you disconnect the power, it could then become a Class A fire if it's the plastic components that are burning.
Yeah, exactly. And they use the letter F for kitchen fires instead of K. But really, regardless of which system is used, the takeaway is the same. You got to know the classification to choose the right type of extinguisher.
Right. And I would imagine using the wrong type could not only be ineffective, but actually dangerous.
Oh, yeah, absolutely. Imagine, trying to put out a grease fire with water.
Oh, that's a recipe for disaster.
Oh, yeah. The water can spread the grease, making the fire much, much worse. So, yeah, it's super important to have the right tools for the job.
Okay, speaking of tools, our sources also talk about these two main approaches to fire safety, and that's active and passive fire protection.
Right, right. So active fire protection systems are those that require, some kind of action or activation to work. Things like fire extinguishers, sprinkler systems, fire alarms. They need a trigger to spring into action.
Right, so they're actively working to either suppress or contain a fire. Now, what about passive fire protection?
Passive fire protection is all about those built-in features of a structure that work to resist and contain fire, even without any active intervention.
So they're kind of like these silent guardians, always working behind the scenes to slow down the spread of a fire.
Yeah, that's a great way to put it. Think about fire-resistant walls and doors, fire-retardant building materials, compartmentalization to contain a fire to a specific area, protected escape routes. Those are all passive fire protection measures.
So it's like building in these layers of protection, right?
Exactly. Ideally, you want to prevent a fire from even starting in the first place, but you also have to have measures in place to limit its spread if one does happen. So both active and passive fire protection systems, those are essential parts of a comprehensive fire safety plan.
Okay, so we've talked about the elements of fire, how it spreads, how to classify it, the different types of protection systems. But what about actually putting a fire out? Our sources really go into detail about the fundamental ways to extinguish a fire.
Right.
Can you walk us through those?
Yeah. So remember the fire tetrahedron we talked about earlier? Fuel, oxygen, heat, and the chemical chain reaction. Well, to extinguish a fire, you need to remove or interrupt one or more of those elements.
So it's like attacking the fire at its source.
Exactly. The most common techniques are cooling, smothering, and starving. So cooling involves lowering the temperature of the burning material below its ignition point.
Like using water to put out a wood fire, right?
Precisely. The water absorbs the heat and cools the fuel, stopping that combustion process. Then there's smothering, which involves cutting off the oxygen supply to the fire.
Like putting a lid on a grease fire or using a carbon dioxide extinguisher.
Exactly. You're essentially depriving the fire of the oxygen it needs to burn. And then lastly, you have starving, which involves removing the fuel source.
So if you have a gas fire, you might shut off the gas valve to starve the flames. Or if you have a wildfire, firefighters might create fire breaks to remove the fuel and prevent it from spreading further.
Yeah, exactly. Each of these techniques targets a different element of that fire tetrahedron, effectively breaking that chain reaction and extinguishing the fire. Now, there's also a fourth method, which is to interrupt the chemical chain reaction itself. Some chemical fire extinguishing agents work in this way, interrupting those complex chemical processes that sustain the fire.
Okay, so that sounds pretty high tech.
It is. And often, effective fire suppression involves a combination of these techniques. Like using a water mist fire extinguisher. That involves both cooling and smothering the flames.
Oh, so that's like a multi-pronged attack.
Exactly.
Well, wow, we've covered a lot of ground here, but there's still so much more to discuss.
Oh, yeah.
And we're back with more key safety talks. Before we took a break, we were really getting into the nitty-gritty of fire, how it starts, how it spreads, the different classes of fire.
Yeah, it really is fascinating stuff. Fire is this, primal force, but there's so much science behind it.
It really is.
Yeah.
And understanding that science is what helps us develop these effective ways to protect ourselves. Speaking of protection, we mentioned fire detection systems a little earlier, and it seems like our sources really emphasize just how important that early detection is.
Oh, absolutely. Early detection can literally be the difference between, a small contained incident and a full-blown catastrophe. Think about it. The sooner you know there's a fire, the sooner you can start evacuating people, and the sooner firefighters can get there and, get things under control.
That makes a lot of sense. So before the break, we touched on the different types of fire detection systems out there. Smoke detectors, flame detectors, heat detectors, but can we get a little bit more technical? How do these systems actually work?
Yeah, sure. Let's start with the most familiar one, the smoke detector. There are two main types, optical and ionization. So optical smoke detectors, they have this little chamber with a light beam shining across it. And when smoke gets into the chamber, it scatters that light, which then triggers the alarm.
So the smoke is basically breaking the beam.
Yeah, exactly. Now, ionization smoke detectors, they work a little differently. They have a small amount of radioactive material that ionizes the air inside the detector, and that creates an electrical current. So when smoke particles get in there, they disrupt that current, which then triggers the alarm.
Wow, that's pretty high tech. So they're both detecting smoke, but just through these different mechanisms. Is one type better than the other?
It really depends on the situation. Ionization detectors, they're generally better at detecting fast-flaming fires, those that produce smaller smoke particles, while optical detectors are better at detecting those smoldering fires that produce larger, more visible smoke particles. So often, the best approach is to actually have both types installed for the most comprehensive coverage.
That makes sense. Kind of a two-pronged approach to detection.
Yeah.
What about flame detectors? How do those work?
Flame detectors are specifically designed to detect the radiation that's given off by flames. So they're super sensitive to infrared or ultraviolet light, which, are given off by open flames.
So they're actually seeing the fire itself, not just the smoke.
Exactly. And they're typically used in areas where fires are likely to develop quickly or where there might be a lot of, dust or other particles that could trigger a false alarm on a smoke detector.
Oh, so they're more specialized than smoke detectors.
Mhm.
You're thinking more like industrial facilities where you might have flammable liquids or processes that could ignite suddenly.
Exactly. Aircraft hangars, fuel storage facilities, other, high hazard environments, those are all places you'd see them. Now let's talk about heat detectors. We mentioned earlier that there are two main types, fixed temperature and rate of rise.
Right. Can you remind me of the differences again?
Yeah, so a fixed temperature heat detector, it's set to go off when the temperature in the room reaches a specific level, kind of like a thermostat for fire, once the heat hits that threshold, boom, the alarm sounds.
So it's a pretty straightforward system. What about rate of rise detectors?
Rate of rise detectors are a little more sophisticated. They're designed to detect a rapid increase in temperature, even if the overall temperature hasn't actually reached that, critical level yet. They're especially useful in areas where a fire could cause a really sudden surge in heat.
Okay, so they're more sensitive to quick changes in temperature. So if the temperature jumps up quickly, even if it's still relatively cool, they'll still go off.
Yeah, exactly. So you often see those used in places like attics, where temperatures can really fluctuate a lot.
That makes sense. So with all these different types, how do you know which type of detector is the best one for a given situation? I mean, it seems like there are so many options.
Yeah, that's a great question. And honestly, it depends on a lot of factors. It depends on the type of building, the potential fire hazards that are present, and even those local fire codes. So often, the best thing to do is actually consult with a fire safety professional. They can, assess those specific risks and recommend the most appropriate system for your needs.
Right, because they have the expertise to really tailor that system to what you need.
Yeah, exactly. They can help you create a layered approach, combining different types of detectors to really get optimal coverage.
Okay, so we've talked about all the different types of fire detection systems and how they work, but let's move on to something I think everyone should know how to use. Portable fire extinguishers. We've all seen them, but do we really know how to use them effectively?
That's a really good point. I think a lot of people assume, using a fire extinguisher is just point and spray, but there's actually a technique to it.
That's right. And our sources mention this acronym, PASS, which stands for pull, aim, squeeze, sweep. Can you walk us through that?
Absolutely. So first you pull the pin. That's the one that secures the extinguisher's handle,
Hmm.
and that releases the locking mechanism. Then you aim the nozzle at the base of the fire, not the flames themselves.
So not at the flames themselves, but at the base where the fuel is actually burning.
You got it. You want to extinguish the source of the fire, not just the flames on top. Then you squeeze the handle to discharge the extinguishing agent. And finally, you sweep the nozzle back and forth across the base of the fire to make sure you're covering the whole area.
Like a little dance move. But seriously, that sweeping motion seems super important for actually getting good coverage.
Yeah, it is. And you got to keep sweeping until the fire is completely out.
Okay, so pass, that's the key to using a fire extinguisher effectively. But before we even get to that point, we need to make sure we're actually using the right type of extinguisher for the type of fire we're dealing with.
Oh, absolutely. We talked about the different fire classes earlier, A, B, C, D, and K, and each class needs a specific type of extinguishing agent. Using the wrong one can not only be ineffective, but also pretty dangerous.
Can you give us some examples of that?
Yeah, sure. So for a Class A fire, which involves ordinary combustibles like wood, paper, cloth, you'd want a water or foam extinguisher. They're usually the best choice because they cool the burning material and help smother those flames. But if you have a Class B fire, which involves flammable liquids or gases, then you need something different, right?
Right. You need something specific for that.
Yeah. So for Class B fires, you typically use a carbon dioxide or a dry chemical extinguisher. And these work by displacing the oxygen, interrupting that combustion process. But using water on a flammable liquid fire, that could be a disaster. It could actually spread the fire.
Okay, yeah, not a good combination. What about electrical fires? Those Class C fires?
For Class C fires, you need an extinguisher with a non-conductive extinguishing agent, to avoid electrocution. So typically carbon dioxide or a special dry chemical powder are used for those. Again, water is a no-no.
Right, of course. And then we have those Class D fires with the combustible metals. And I imagine those need a very special type of extinguisher.
Exactly. Class D fires need a specialized dry powder extinguishing agent that can smother the burning metal and prevent it from reacting with oxygen. And these fires, they can be particularly hard to put out because they burn at such high temperatures.
It's amazing how many different types of extinguishers there are. And then, of course, we have the Class K fires for those kitchen fires,
Yeah.
Involving cooking oils and fats.
Yeah, that's right. Class K fires, those are best extinguished with a wet chemical extinguisher. These extinguishers use a special agent that forms that, soapy foam blanket over the burning oil, which prevents it from reigniting.
So it's like a special firefighting recipe for that type of fire.
Exactly.
So the bottom line is, Knowing the correct fire class
Yeah.
and then using the right type of extinguisher. I mean, that's absolutely critical.
Yeah, I couldn't agree more. It's also important to remember that even if you have the right extinguisher, you also need to know how to use it properly. That pass technique we talked about earlier, that's crucial.
And even with all this knowledge, sometimes it's just best to get out and let the professionals handle it.
Oh, for sure. Your safety is always the number one priority. So if you're unsure about how to use an extinguisher or, if the fire is growing rapidly, always best to evacuate the building and call the fire department.
Good point. Good point. Now, shifting gears a bit, let's talk about those kind of built-in heroes we mentioned earlier, the automatic sprinkler systems. These seem like such a critical part of fire protection in a lot of buildings.
Oh, yeah, absolutely. I mean, sprinkler systems, they're often the first line of defense in a fire. They're designed to detect that fire and automatically activate so they can suppress or even extinguish the flames before they really get a chance to spread. It's pretty amazing technology.
Yeah, it really is. Now, our sources go into some detail about all the different types of sprinkler systems out there. We've got dry pipe, wet pipe, deluge, pre-action, water spray, foam water. It seems like there's a sprinkler system for every situation.
Yeah, you're right. There are a lot of different varieties out there, and each type has its own, advantages and disadvantages.
So where do we even begin with all these options?
Well, let's start with the most common type, which is the wet pipe system. It's pretty simple, really. The pipes are always filled with water under pressure, and when a sprinkler head gets activated, water just starts flowing immediately.
Okay, so it's ready to go right away.
It is, but there's a catch. Wet pipe systems aren't suitable for areas where freezing temperatures are a concern. I mean, can you imagine the damage if the water in the pipes froze, expanded, and boost those pipes?
Yeah, that would be bad. So that's where dry pipe systems come in, right?
Exactly. So in a dry pipe system, the pipes are filled with pressurized air or nitrogen instead of water. When a fire is detected, the sprinkler head opens, it releases that air pressure, and then that allows water to flow into the pipes and out those sprinkler heads.
Okay, so there's a slight delay before the water starts flowing, but it prevents the pipes from freezing in those colder environments.
Precisely. You often see dry pipe systems in places like, unheated warehouses or parking garages where freezing is a real concern.
Okay, that makes sense. What about those deluge systems? Our sources mention those being used in high-hazard areas. They sound pretty intense.
Oh, they are. Deluge systems, they're designed for situations where you need like a really rapid and widespread water discharge. So all the sprinkler heads are actually open and the pipes aren't filled with water until the system is activated. So when a fire is detected, a massive amount of water is released, all at once, completely drenching the entire area.
Wow, that's like a firefighting waterfall.
Yeah.
Where would you typically see these deluge systems being used?
Well, think about places like aircraft hangars, chemical storage facilities, or areas with, highly flammable materials. You want to suppress that fire as quickly and completely as possible in those situations.
Right, minimize the damage and keep the fire from spreading out of control. Now, our sources also talk about pre-action systems. How are those different from the other types we've discussed?
Pre-action systems, those are a bit more complex. They're kind of like a hybrid between a dry pipe and a wet pipe system. So like dry pipe systems, the pipes aren't filled with water initially, but before the water is released, there's an extra step. Typically, a fire detection system, like a smoke detector or a heat detector, has to trigger the system first.
Okay, so it's like an added layer of verification before that water flows.
Exactly. Once that fire detection system triggers the pre-action system, the pipes are filled with water, and then when a sprinkler head is activated, the water is released, and that helps prevent those accidental discharges, which can sometimes be a concern with those wet pipe systems.
Makes sense. I can imagine there are certain situations where you don't want water damage from an accidental sprinkler discharge, like a museum or a data center or something like that.
Yeah, those are great examples. You often see pre-action systems used in places where that water damage would be a major concern.
Right. Okay, so the pre-action system provides that extra level of protection. What about water spray systems? How are they different from like your typical sprinkler system?
Water spray systems use special nozzles that create like a fine mist of water droplets instead of those larger droplets you see with traditional sprinklers. This mist is really effective at cooling and absorbing heat, which makes it, very efficient at suppressing fires.
So they use less water but are still really effective.
Yeah, and because they use less water, they cause less water damage too.
It's like a win-win situation. Finally, our sources mention foam water sprinkler systems. What are those all about?
Foam water sprinkler systems combine water with a special foam concentrate to create a fire-suppressing foam. And this foam is especially good for those flammable liquid fires as it blankets the liquid surface, cuts off the oxygen supply, and prevents more flammable vapors from being
Oh,
released.
that's pretty specialized.
It is. You see foam water systems often in places like oil refineries, fuel storage facilities, and chemical plants where flammable liquid fires are a major risk.
It's really amazing how each type of sprinkler system is like tailored to a specific type of fire hazard. I mean, it really speaks to the ingenuity of fire protection engineering.
I agree. And it just highlights how important it is to work with a qualified fire protection professional to make sure you have the right system for your needs. They can evaluate the risks, design the system, and make sure it's properly installed and maintained.
That's a great point. It's not a one-size-fits-all solution. So to wrap up this episode of Key Safety Talks, it's clear that fire protection is a really complex field with so much interesting science and technology behind it.
Oh, absolutely.
And while we covered a lot today, there's always more to learn. So we encourage you to check out those resources from organizations like the NFPA and the National Fire Sprinkler Association. And, talk to fire safety professionals. Make sure your homes and workplaces are protected.
That's great advice. Fire safety is really everyone's responsibility.
Absolutely. By understanding the hazards, taking preventive measures, being prepared, I mean, we can all do our part to minimize those risks and stay safe.
Well, thanks for having me on Key Safety Talks. It's been great talking about this important topic with you.
Thanks for being here. And to all of you listening, remember, stay safe out there. And we're back with Key Safety Talks. Before the break, we were talking about all those amazing sprinkler systems, those kind of unsung heroes of fire protection. It really does sound like there's a whole world of sprinkler technology that, most of us just aren't aware of.
Yeah, I think you're right. When most people think about fire safety, they picture, grabbing a fire extinguisher. But a lot of times, it's the sprinkler systems that are doing the real heavy lifting behind the scenes. They can literally be the difference between a small contained fire and a huge disaster.
Okay, so let's dive into those different types of sprinkler systems. Our sources mention dry pipe, wet pipe, deluge, pre-action, water spray, foam water. It's a lot to wrap our heads around. Where should we start?
Well, let's start with the most common type, which is the wet pipe system. And it's pretty straightforward. The pipes are always filled with water under pressure, and when a sprinkler head is activated, water flows immediately.
So it's ready to go at a moment's notice.
Yep. But there's a catch. Wet pipe systems, they're not suitable for areas where freezing temperatures are a concern. Imagine the damage if the water in the pipes froze and expanded. You'd have burst pipes all over the place.
Oh, yeah, that would be a major problem. So that's where dry pipe systems come in, I'm guessing.
Exactly. So in a dry pipe system, the pipes are filled with pressurized air or nitrogen instead of water. And when a fire is detected, the sprinkler head opens, releasing that air pressure. And that's what allows the water to flow into the pipes and out the sprinkler heads.
So there's a bit of a delay before the water starts flowing, but it prevents those pipes from freezing in colder environments.
Precisely. You often see dry pipe systems in places like unheated warehouses or parking garages, where those freezing temperatures are a real issue.
That makes a lot of sense. Now, what about those deluge systems? Our sources mentioned them being used in those high-hazard areas. They sound pretty intense.
Oh, they are. Deluge systems are designed for situations where you need a rapid and widespread water discharge. So all of the sprinkler heads are open, and the pipes are not filled with water until the system is activated. So when a fire is detected, a huge amount of water is released all at once, just drenching the whole area.
Wow, it's like a firefighting waterfall. Where would you typically see these deluge systems?
Well, think about places like aircraft hangars, chemical storage facilities, or areas where you have, highly flammable materials. In those situations, you want to suppress that fire as quickly and completely as possible.
Right, minimize the damage and, keep that fire from spreading out of control. Now, our sources also talk about pre-action systems. How are they different from the other types we've talked about?
Pre-action systems, those are a little more complex. They're kind of a hybrid between a dry pipe and a wet pipe system. Like dry pipe systems, the pipes aren't initially filled with water, but before that water is released, there's an additional step. Usually, a fire detection system like a smoke detector or a heat detector has to trigger the system first.
So there's like an extra layer of verification before that water flows.
Exactly. Once the fire detection system triggers that pre-action system, the pipes are filled with water, and then when a sprinkler head is activated, the water is released. This really helps to prevent accidental discharges, which, can be a concern with those wet pipe systems.
Yeah, I can see that. I mean, there are certain situations, like in a museum with priceless artifacts or a data center with sensitive equipment, where you really don't want water damage from, an accidental discharge.
Yeah, exactly. You often see pre-action systems used in those types of places where water damage would be a big problem.
Right. Okay. So pre-action systems offer that additional layer of protection. What about water spray systems? How are those different from more traditional sprinkler systems?
Water spray systems, they use special nozzles that create a fine mist of water droplets instead of those larger droplets you get with a traditional sprinkler. And that mist is incredibly effective at cooling and absorbing heat, which makes it really efficient at suppressing fires.
So it uses less water overall, but it's still very effective.
Exactly. And because they use less water, you have less water damage too.
Okay, so it's a win-win.
Yep.
Finally, our sources mentioned those foam water sprinkler systems. What's the story with those?
So foam water sprinkler systems combine water with a special foam concentrate, and that creates a fire-suppressing foam. That foam is particularly effective on those flammable liquid fires because it blankets the surface of the liquid, cutting off the oxygen supply and preventing more of those flammable vapors from being released.
That sounds pretty specialized.
It is. You often see foam water systems in places like oil refineries, fuel storage facilities, chemical plants, basically anywhere that flammable liquid fires are a big concern.
It's amazing how each type of sprinkler system is like custom made for a certain type of fire hazard. It really shows how smart fire protection engineering is.
Yeah, I agree. And it just goes to show how important it is to work with a qualified fire protection professional, someone who can make sure you have the right system for your needs. They can evaluate the risks, design the system, and make sure it's installed correctly and properly maintained.
That's such an important point. It's definitely not a one-size-fits-all kind of thing. Well, we've covered so much ground today. It's clear that fire protection is a complex and fascinating field with a ton of science and technology behind it. And while we learned a lot today, there's always more to know. So we encourage you to continue exploring fire safety. Check out the great resources from organizations like the NFPA and the National Fire Sprinkler Association. And talk to those fire safety professionals to make sure your homes and workplaces are as safe as they can be.
Couldn't have said it better myself. Fire safety really is everyone's responsibility.
That's right. And by understanding those hazards, taking preventative measures, being prepared, I mean, we can all do our part to minimize those risks and just stay safe.
Well, thanks again for having me on Key Safety Talks. It's been great talking about this with you today.
Thanks for being here. And all of you listening, stay safe out there.